Thank you. Thank you, guys. Yeah, so nice to see you all. My name is Nizar Selander, and I created a little helpful tool, I think it's helpful, for Cloud Code to enforce test-driven development. But before we start, I think it will be nice to get to know a little bit about you guys. So raise of hands, who uses LLMs or applications like ChatGPT for programming? That's the majority, I would say. Who here uses agents for programming purposes? That's, I don't know, that's more than half the people. That's surprising, and that's good to know. Who here watches Formula One? I'm just trying to scout you guys later for the pizza. And all right, good. We'll go. That wasn't relevant. I'm just a curious person. So we'll go to the next slide. So a little bit about me. I started using LLMs like around ChatGPT 3.5 or something like that. But the way I used it was maybe slightly different than what's typical. I like to ask questions, explore solutions, rubber ducking, kind of like almost like asking a colleague or someone over your shoulder, get second opinions, things like that. So I preferred not to have it generate the code or copy paste it. I was kind of like very strict about it. I wanted to have full control. It should be my own code. And that was something that I stuck by for a very long time until I tried Cloud Code. And that's when things changed for me. And if you're familiar with ChatGPT, usually starts with giving some kind of like context, some background, what you're working with, and you kind of decide the order. You feed it the information. You're kind of like a coordinator of the whole thing. You're in charge the whole time. But with agents, they have autonomy. They can decide which tools to use, when, and in which order, and things like that. And with this autonomy, of course, you get some productivity, but discipline sometimes takes the backseat. So, for example, you see it skip over writing tests, or write a lot of tests at once, or over-implement, or do things not the way you like. And so that's something I missed, having this control over the agents compared to when I used to interact with ChatGPT. And yeah, so that's why I basically started creating this TDD Guard. It's to kind of like enforce test-driven development. And so another raise of hands, who here is a test-driven development practitioner? Wow, okay, that's impressive. Almost everyone here. All right, cool. Should we skip this slide then? But yeah, TDD is good. Let's keep it this way. I don't think we have to go about it. But yeah, it's very important to me, and I wanted to make sure that the agent adheres to it and it's enforced mechanically. And when it comes to agents, one definition of agents is that they are basically LLMs autonomously calling tools in a loop. And this loop typically looks something like this. Once you start it, you give it a prompt, for example, like create a dark mode toggle or something like that. So it gathers the context about the project, what files are there, test helpers, things like that. It makes the modification. Things are reasonable. It verifies the work, maybe run some tests, something like that, and it iterates. And this is very powerful because it allows it to recover if it encounters something surprising, unexpected, errors, things like that. But as we said, the more autonomy we give it, the more it gets to kind of like decide on the sequence and in what order to do things. And they're usually trained for completion, not for discipline. And that's kind of like, that's the challenge, really. So from developing TDD Guard, I've learned a few things that I thought I'd like to share with you guys. So the first one is the value of dog fooding your instructions, or basically consuming them as you develop them. And delegating for focus, how to kind of, make sure your agents are focused. They have only the information they need when they need it. You don't front load everything. How to enforce things in a deterministic way, so you don't just rely on trust that it will do the right thing. And how to provide it with mechanisms or tools to verify its own work. All right, so one thing you would notice when you work with agents for the first time, or let's put it this way. When I used ChatGPT, I would always start with saying like, "Hey, I'm working on a project that uses React with this and that, and I would like to do blah blah blah." And you find yourself repeating the same kind of like backdrop or kind of like context over and over again. And ChatGPT came with this functionality or feature where I think it was called like custom instructions or something like that. So you can just write them once and you don't have to repeat yourself as much. And I tried it once. I basically said like, hey, I'm very strict about test-driven development. Always start with a failing test. And I didn't think much of it until one day I asked it about how to make hummus. And it answered me with a failing test. So I felt like maybe that wasn't the so I didn't use them as much. However, when you're working with agents, it makes more sense to have like persistent instructions. And this is typically a file called like claude.md or something like that. And it's very natural to think like, oh, I don't have to repeat myself over and over. Let's just write everything, tell it everything it needs to do, every preference I have, things like that. And it's a very natural thing. I think most of us have done that, but it's not ideal because you're basically giving it too much information. The vast majority of it is not even relevant, and the agents or the models, they tend to they find it difficult to prioritize, and then you feel frustrated, feel that they don't really follow exactly what you're instructing them to do. So these days I prefer to start as minimum as possible, just what it needs to know. What's this project about? What tools should it use? Commands, things should it know? Just start with the absolute minimum, and then just use it. Make sure once you encounter like a fail mode, you just correct only for that one. This way, every instruction you add to this file, it earned its place. And I found this to be the most helpful one, instead of like kind of like just guessing what is good to have and so on. And I can share a story how I encountered this. So when I released the first stable version of TDD Guard, I thought I would make it easier for users to customize the validation instructions. And while I was doing that, I thought I would also chase some optimizations. So for example, like compacting the instructions a little bit, making them more concise, things like that. Because I thought like the more concise they are, the less the models have to reason about them, and it will be a bit faster validation. But when I did that, they looked cleaner. It's smaller instructions, less repetition, I thought, but they didn't work as well because I lost all the real world dog-fooded instructions. So I had to, put my tail between my legs, or what do you call it, and ship a new fix and revert it back. So that was probably the biggest lesson. Field hardened, proven instructions are always better than theoretical guesswork. So we've now talked about the importance of being deliberate with instructions. Let's talk about delegation. So models have this thing called the context window. It's kind of like everything the model sees at once. Think of it like the working memory. And it's a very finite resource. So every time it reads a file, it searches for something, it adds this to the context window, and it quickly fills up. The thing is, most of this information that it reads is not really relevant later on. It's not important. So it quickly fills up. And agents have this way to deal with this by basically compacting it, replacing it with a summary, so to keep what is important. But this process of it filling up quickly is also not very effective. And we're seeing progress in the models by basically getting larger and larger context windows. The thing is, like for example, some might say like, a million or something like that. One way they test this is this needle in the haystack. So they basically fill up the context window with a lot of text. And then they would ask like an agent or model, like find a specific phrase. And they tend to succeed with it. They tend to find the exact phrase, exact word. The problem is real work is a little bit more challenging. It requires reasoning, making connections, things like that. And that's where real degradation shows up. So one way to fight this context pollution, if we go back to how we, or at least I use ChatGPT, I would kind of like hand feed it the information. So I wouldn't just like throw a lot of files at it. Um, we can basically have an agent, just like it can call on a tool to do a certain task. We can have an agent call on another agent and say, hey, go read those files and give me what I want to know. This way, it will return only the important results. And everything that's not important is not contaminating or polluting the main context window. And that's a very effective way of making sure you don't fill up this context window very quickly with a lot of information that has very little value or relevance. So, the next one. So imagine you go back home tonight. Oh, actually, I'm gonna make pasta. I forgot to do pasta. So I'll use my example. So when I cook, I would bring only what I need to prepare for at this current step. And we do that because it's easier to work. You just chop exactly what you're gonna need, and you don't put everything in front of you at the same time. And I think it's by following the same principle with agents, you basically give them only the information when they need it, and you basically let them discover what they need when they need it instead. This way you optimize within a single agent's context window. And we'll go to the next one here. So, who here has worked with commit hooks? Yeah, a third. Cool. So they're basically kind of like, it's a way to kind of enforce certain standards, code standards in the code base for developers. For example, you can also enforce them on commits to follow a certain style. And they basically, when you start creating a commit, they might check the formatting or the styling, linting, things like that. And if it encounters any issue, it would basically block the whole process and tell you to fix it. We can use the same hooks also for agents. So we can, this is actually a better way to, for example, if we have certain programming preferences like functional programming and so on, maybe use linting rules to enforce them. And they would also work on agents. We also have Claude. They have their own hooks, and those are basically, they're kind of like operations that listen to what the agent wants to do, like for example, when it tries to edit a file. And this is what we use to validate test-driven development. We, for example, see what is the agent trying to modify, what is it trying to add, has it run the tests, are the tests relevant, is it trying to add maybe more than one test at a time, things like that. And that's how we make sure that it follows test-driven development. And finally, we'll talk about feedback loops. So you might have noticed or seen that agents, or at least Claude Code, is better at TypeScript compared to JavaScript because of the typing system, because it acts as an additional layer of feedback that gives a high signal immediately when something is wrong, like a type or something like that. And this allows the agents to quickly correct course at a much earlier point, so before things accumulate and so on. And tests give this kind of mechanism as well for the agents to reason, get objective feedback very quickly when something goes wrong. And especially behavior tests that convey the intention, they make it easier for the agents to discover on their own. You don't have to explain as much, and they also serve as living documentation. And here's a little bit of demo of how TDD Guard looks like in action. I'm gonna full screen this here. So I think I'm using, let's see, what's this? Yeah, this is TypeScript. We have basically a very simple file here. about kind of like what to do, different scripts and main features. Then we have over here basically some kind of like business requirements and functionality that we want. And we start over here, this is where we have Cloud Code. We basically say, take a look at those 2 files and start development. We don't want to say anything about test-driven development or anything like that. We just want to see how it works normally. So this is sped up a little bit, but you can see that it immediately has read a few files here. They're empty. It's checking different things. And then it created a to-do list, and it's going to start working on it. And we have TDD Guard basically installed, and it's going to basically listen to those whatever the agent is going to try to do. So the first thing you see here is in red. This is TDD Guard acting here. It's blocked an operation using the hook, and it's noticed that, hey, you're trying to make changes to the cart, and you have to. It also nudges it in the right direction and tells it what it needs to do. For example, you have to write you make sure that you start with a failing test, and we can see here that the agent understood. I see. The project's using TDD. Let me start by writing a failing test. All right. So here comes the first failing test, and now let me create the minimal implementation to make this. Thing is, I don't think it ever ran the test. So we also block it. You have to also make sure it fails. So we can see here. Does it understand? Let me run the test first to see it fail. And now it's failing. And then we block it again. And now over implementing here. As we can see, over implementation. So basically, it's very strict. It has to follow test-driven development. Everything has to fail first and so on. And I'm just gonna let it go a little bit, but as you can see, it forces it to refactor when it senses that it's time to kind of clean up some things using lint rules. We also have, keeps adding tests, and it blocks over implementation. For example, let's see next time. Let's see here. Multiple test addition violation. It tried to add more than 1 test at a time. That's cheating. I don't know. It might be slower with just 1 test at a time, but that's just, I think it's worth it. And soon we'll just see like the final result, how it looks like. So after some refactoring. So we basically, with the help of TDD Guard, we're able to get very good tests over here, and we have also enforced some refactoring and some rules here, which looks like a much better improvement than what it would have done without it. And that was everything and for my presentation. And please let's connect on LinkedIn or GitHub. And I look forward to eating some pizza with you guys.